The last section in Chapter 3 is Section 3.9, and it's only 2 objectives. These are 2 concepts you have not learned about before, but they are not overly difficult. You're going to interpret what a z-score means, and then you're going to compute z-scores and make decisions about comparing scores. Let's get to the first slide. If I present you with this question, which test did an FST student do better on? Was it the Chapter 1 statistics test where they got 27.5 out of 33? Or was it the Chapter 2 functions test where they got 26.5 out of 33? If you look at just the raw score of what the students got, the odds are you're going to say they did better on the Chapter 1 test. But this is not necessarily the right answer. Here's the problem with saying it's a Chapter 1 test, are the topics. The Chapter 1 test was on statistics and the Chapter 2 was on functions. They're 2 completely different topics, which means they're not comparable. It's not like you're comparing apples to apples. This is what they would say is you're comparing apples to oranges. What we do in mathematics, there's a thing called the z-score, and it helps us standardize data so it's actually more equitable and comparable with each other. And that would be the case with this. So what we're going to do is let's jump into the z-score and then do some problems to help you better answer this type of question. Okay, what a z-score is, it's the number of standard deviations a piece of data is from the mean. And this is actually the calculation right here. The shorthand is z-score. This general X right here is your piece of data, your score. X bar is the class average or the sample's average, and S here is the standard deviation. So this is the sample mean. This is the sample standard deviation. And then again, the X is just the piece of data we're talking about. So if we were talking about, again, the stats score from Chapter 1 or the Chapter 2 test, what I'd want to do in that last example is to look at the class average and the class standard deviation and compute their z-scores. So let's talk about how the calculation works. If when I compute a z-score, I get a positive answer, again, let's go back and talk about the stats test. If I had gotten a 27.5, and let's just compute a z-score for that. Let's say my z-score would be my test score of 27.5. I would want to know the class average. Let's say that the class average was 21.5 points. So I would minus 21.5 points. And the standard deviation is on average how many points the standard student deviates from the mean. So do they deviate 2 points from the mean, 3 points from the mean, 4 points from the mean? Let's say the standard deviation was 3 points. Okay. If you compute the z-score, the top is going to be 6 over 3, which is the number 2. This would be a z-score of 2. That is a positive number. So if the number is positive when you compute the z-score, means our particular piece of data right here, if you notice, is clearly above the class mean. Now if I were to compute a z-score that was negative, I would get a negative z-score if my initial score was smaller than the mean or below the mean. So you can easily tell by just the quantitative value of the z-score if a person did above the class average or below the class average. Now terminology is the raw data or scores. This is just the original data. And in this case, the raw data we are dealing with was my score of 27.5 points. The standardized data or the score is what we call the transformed data. And the transformed data is the z-score itself. Okay, let's take a look at how to apply this in example 1. Nancy scored 87 on a math quiz with a mean score of 70 and the standard deviation of 8. Find her z-score and tell how far her score was above the mean. Again, z-score calc is going to be your piece of raw data minus the average over the standard deviation here of 8. This is going to be 17 over 8, and I'm going to simplify that to a decimal, which gives me 2.125. Now, tell how far her score was for the mean. Here's how you would say it. You would say that Nancy's score is 2.125 standard deviations. Now, do we say above or below? Here it's going to be above the mean. So the standard deviation of the class is 8 points. She's 2.125 standard deviations above the mean, which means she's over 16 points above the mean. Well, yeah, she was 17 points above the mean. And that's how you interpret that. Now, I want to just kind of help you understand why we even cover the z-scores now in Chapter 3. In Chapter 3, we translated, which was adding or subtracting, or slid data, and we scale changed, which is multiplying or dividing, or stretching data. Well, a z-score is just a combination of both a translation and a scale change. When we take here the piece of data and we subtract the mean from it, that is actually a translation of data. Then when we take that number and we divide it by the standard deviation, division or multiplication is just a scale change of data. So what we've done is it's called a transformation. This is a transformation which was comprised of both a translation and a scale change. Now the z-score, I'm not going to go into the specific details, but it's just function composition, which is what we talked about. If I take the translation, the t of x, which is this right here, and if I embed it into the s of x, which is this function down here, if I plug that into there, what you get is the formula for a z-score. Okay. Now, let me show you this computation. Imagine this is the data in the calculator, and we have right here list 1 in the calc. Let's say list 1 is just all the raw scores. And be careful, this right here got dropped down. It shouldn't be that far into the data, so just ignore that. But let's just highlight, for example, the number 73, if that is a raw score. What they want us to do is to translate this by subtracting 70 and then come in and do a scale change and divide by 5. So what they did is they took the 73 minus 70 and they got the 3. So this right here is the t of x function, or the translation. Okay. Now they come in, they take 3 and they divide it by 5. So when you take 3 and divide it by 5, you get 0.6. This is the scale change. So what we've done is list 3 here has taken all of the data in list 1, which is all the raw scores, and it's computed everyone's z-score. Now here's what's interesting, is if you take all of these z-scores that I just put a box around and you add them up and find their average, just take a look at the numbers. If you add up, right here we have a, for example, here's a negative 0.4, here's a positive 0.4. Here's a negative 0.8, here's 2 0.4s, which is a positive 0.8. A 0 and a 0 cancel out. What happens is when you average these up and divide by how many pieces of data there are, you're going to get that the mean of all the z-scores is 0. And that is actually going to happen to every single data set you take. That's why a z-score works and is comparable across a Chapter 1 test or a Chapter 2 test if they're different topics. What we do is we standardize the data such that the data set has the same mean, which is 0. The standard deviation then of all of these z-scores, I will tell you, is just going to be 1. Now, you're not going to have to worry as much about kind of the theory behind where the z-score comes from like we just talked about, but it's going to be something like this. This is a great example of what you may be tested on. Let's see if you can determine the answer. Mark scored 78 on a history test, which the mean was 71 and the standard deviation was 10. He scored 68 on a chemistry test, on which the mean was 62 and the standard deviation was 6. Use z-scores to determine on which test he performed better compared to his classmates. Now the one thing too we'd want to caution you about the z-scores, we want to know that it's the same sample that we're using. So this is where sometimes it's not the best measurement to use, but it's a better measurement by computing a z-score. We're going to assume that there was the same students that took both the history and the chemistry test. Fine. Let me do one calc for you. Let me do the z-score of the history. So I'll do z of history is my history score minus the mean over the standard deviation. And that's just going to give me a 7 over 10, which is the same as 0.7. Okay. Positive z-score seems good. I want you to pause the video and compute for yourself the Z-score for the chemistry test. So go ahead, pause the video, do the Z-score, turn it back on, and see if you got the right answer. Did you get the Z-score on the chemistry test? Was 1 standard deviation above the class average. In doing this, we can now decide which test did he do better on. And this should actually say history and chemistry, so ignore those. Clearly, he did better compared to the class on his chemistry exam. So folks, this might be a good thing to do if you're in chemistry and you don't do well on a test. Ask the teacher for the mean and standard deviation of the class. Maybe you go home that night and instead of telling your folks you got a 68 or a D+ on the test, you compute your Z-score. Put a little math spin in there. Maybe it'll help you be able to cushion that a little bit more with them. Because a Z-score of a +1, that's a good thing. That's better than the average, which in theory is, if you think of the average as a C, it sounds better. So just a thought. One more example, let's take a look at it. I'm going to tell you the hardest thing about this section, and it's not that hard, is just reading the context of the problem and really being careful in answering the question properly. So I'm going to challenge you to go ahead and let's read this question, and then I'll have you pause the video and see if you can answer it. So Melvin scored 83 on a test with a mean of 90 and a standard deviation of 6. He scored 37 on a test with a mean of 45 and a standard deviation of 5. Which test did he score in a lower percentile? Pause the video, compute the Z-score of test 1 and test 2, answer the question, and then turn the video back on, and let's see if you got the correct test. So go ahead, pause the video. Okay, you should have come up with these two corresponding Z-scores. On the first test, he's negative 1.16 repeating, so he is deviated below the class average by 1.16 deviations. On test 2, he is 1.16 standard deviations below the class average again. So be careful on which test did he score in the lower percentile. Your answer to this problem would have to be test 2. That is the one that he did worse on. Now, that's it for Z-scores. Again, let's see how you do on the entrance card. Hopefully you get modified. If not, here's your standard assignment. And please feel free to let me know what questions you have on this homework.